houses as an idea. I would really want to stay in one just so that I can say I'm staying in a rock and roll house, if nothing else.
So one thing that people always gets wrong about earthquake is that people think earthquake kills people. That's actually not true.
Are you sure about that?
I would have thought of earthquakes and like things that are happening on Earth to be so cool.
I don't think my kindergarten teachers use that kind of an example to explain.
You were just chilling with other kind of stars. We were chilling with other kind of stars.
I like that. It was actually a blue whale, and the comments, I was reading the comments, of course. The comments are more interesting than the post, always. So
more than 200,000 tweets. 200,000 tweets.
I mean, all I did during the lockdown was discover a lot of K-dramas and K-pop boy bands.
Hi everyone, and welcome to the second episode of Smurf House, a podcast where we discuss mostly space stuff, but also end up rambling about a host of other topics from K-pop to NFTs. This is your host, Pooja, aka the Wandering Stargazer, and we have
Alina, who is the potentially spaced out space policy person from Space Smurfs. So yeah, I mean, really good to have the second episode of Smurf House today. And today we have none other than Pond, who is one of our design thinking workshop technology mentor that we had with Cosmic Sandbox last year. He is a PhD candidate at the California Institute of Technology, Caltech, and is a geophysics enthusiast with diverse experience in data modeling, machine learning, field geology, and experimental mechanics. Well, that's a lot, but yeah. And he is also the co-lead of Space Technologies for Earth Applications Project Group of SGAC, and also a student member of the American Geophysical Unit. So as you guys might have seen, today's session will be on earthquakes and tsunamis, a peek from outer space. So without further wait, let's the smurfing begin. Yeah.
Perfect. I think the first question that will come to our minds first, Pond, is if you could just explain the science behind earthquake and tsunamis in a very simple manner for all our audience, that would be great.
Yeah, of course, sounds good. So I start with earthquakes, right? So
yeah,
most of us know that it's basically the earth, the ground is shaking basically, and it's trembling. But what caused it is basically that on Earth there are things that we call plate tectonics. So basically the shell of the Earth. So think about, okay, people usually use an analogy with an apple or with an avocado. So the skin of the avocado or the skin of the apple is basically the crust or the outside part of the earth that we are sitting on. And unfortunately, instead of having a continuous skin like most fruits have, there are cracks all over the places because inside the earth it's not just solid, it's liquid. And basically everything is moving. And that's why you have crack on the outside. And on the cracks, once you have this crack, which is basically what we call faults, once they move past one another, you create an earthquakes. So, you know, even though the movement seems small, like if you think about the skin of the apple is moving around, but in reality, the earth is just so huge, right? The thickness of the skin of the apple here is equivalent to something like 50 kilometer of thickness. So it's huge. And the mass of the rock are actually quite heavy. You can go and try haul one outside. It's much heavier than other objects, like, for example, a glass of water. And you can see that basically as these things are moving, you create a trembling motion and basically creating and radiating seismic wave, and it's become an earthquake that we all feel. Now for the tsunamis, if this crack or the faults happen to be under the ocean, and one of them move, then basically the water on top of it will get displaced. So think about, you know, a swimming pool, for example, and you move up the floor of the swimming pool really quickly. Then at the end, the water is going to create a big wave that go that go all over the place. And again, even though if you think about it, the movement here is probably about maybe the faults probably move like a few meters at the time, like 10 meters or so. But the ocean is so vast, and think about the entire ocean lifting up. That's basically displacing a lot of water and definitely creating such a big wave, and that's what we call tsunamis. Note that not all earthquakes are producing tsunamis because on these faults, when things are moving, it can slide like laterally, or it can actually slide vertically. It's the vertical motion here that matters, that create the tsunami.
Okay, I mean, that's actually quite a number of things, like the way you have related it to peeling an apple or the crust of the apple and things. I mean, that I don't think my kindergarten teachers use that kind of an example to explain earthquakes. Wow, that makes it really simpler, I think, right, Pooja?
And also, yeah, he made it sound so cool. Like it's for the first time that I would have thought of earthquakes and like things that are happening on Earth to be so cool. Because otherwise, we've always seen that in the textbook, and it seems so dry and boring.
Yeah. And also the terms that you have, like, it seems like, okay, this is not something that I want to read, but the way that comparison is being done. And I think regarding the oceans also, like recently I saw an Instagram post where there was a picture taken from a plane. I don't know whether it's real or not, but I could actually relate to it because there was this ocean background and they showed a small tiny thing and they were saying that it's a blue whale. And then there was a zoomed in picture. It was actually a blue whale. And the comments, I was reading the comments, of course, the comments are more interesting than the post, always. So the comment section, it was saying that, how they thought that the blue whale was actually as big as the whole ocean. Like, of course, we never think that, blue whale will be like this much small when you compare the whole oceanic area. And imagine how small we are then. Wow. Okay. So anyway, going back to the topic, I think the very recent news, or even that we all heard about tsunamis or something of that sort, was the Tonga volcanic eruption. So I think it also connects to what you just mentioned, that the tsunamis are not only caused by the movement of the plates, the earthquakes, it can be also other things. Again, from your studies and research and the experience that you have had so far, can you give a very good example of any recent event or something of that sort where the earthquake and tsunamis happen, and also the impact to which it has actually affected that particular region or a community living nearby?
Yeah, of course. So definitely the volcanic eruption in Tonga is definitely one of the biggest one. And it's also, as you said, highlight the fact that tsunamis are not only generated by the movement of the earth, but also basically volcanic eruptions and also underwater landslides. So we see landslides on the ground, but these things can also happen underneath the ocean, and it could generate tsunami as well. Now come back to the question about the recent events. So there are many. I guess the most notable one in the past year, I would say, would be the magnitude 7.2 earthquake in Haiti. That is basically quite well. It's quite big, and it's actually damaged a few structures in Haiti as well. But in the past year, there's not much big event. The biggest one in most of our life that we know of is definitely the Tohoku earthquake in 2011. I think everyone would remember this. It was a while ago, so 10 years ago. It's in Japan. And there's also an incident where you have a nuclear power plant, the Fukushima nuclear power plant, right? That's get damaged by the waters from tsunami. So in this case, the earthquakes have an upward motion of the plates as well, and it's produced quite a big earthquakes. Quite a big tsunamis then. Yeah, so that's the one that most memorable to most people. March 2011.
I think when it comes to the impact part, like the presence of such infrastructure, like let's say the nuclear power plant or some other energy generating infrastructure, let's say, it's more dangerous, I will say, right? Like, because it's going to affect a lot of people and maybe even the whole country. Like if it's something like Japan or a small country, it's going to be really bad, right?
Right. Yeah. So one thing that people always get wrong about earthquake is that people think earthquake kills people. That's actually not true. It's really rare that earthquakes itself actually kill people. It is the building collapse or other things that resulting from earthquakes that are killing people. So let's say you stand on a random fault in the desert out out there somewhere, and then you have a big earthquake. You're likely not going to die because you will probably get thrown around, but nothing is going to fall on top of you. So you are likely not going to die. Most death and most of the damage come when you are in the building when you have an earthquake. So basically, the building shakes and things collapse on you. That's why if your country, actually this depends on the countries. If your country has a good building code, which means that the building is supported by there's some law that's actually regulate how buildings are built. If it's regulated to some degree, people always say that when earthquakes happen, what you have to do is drop, cover, and hold on. So basically in Southern California, here in Los Angeles, this is the term that people use. So basically you find a shelter of some sort, you go and hit and hide underneath it. Most of the time, things like tables works really well. So basically stop things that going to fall on top of you. However, if your building is weak though, for example, in Mexico, especially Mexico City, the recommendation is different. If you are in the older building where it's not retrofitted properly for earthquakes, the best method is actually to run outside the building. But also there is, if you are on like 20th floor, you know that you are not going to actually make it down before things happen. So the idea is that if you are within the first or the second floor, run out. Otherwise, if you are above that, you do drop, cover, and hold on still.
Wow.
I
So
mean,
if I'm understanding this right, even if it's a small earthquake comparatively on the seismic scale, but if you're in a place where the infrastructure is not great, it could be more catastrophic for you rather than even if it is like a large earthquake where the infrastructure is better. So that's what I'm understanding, and that makes me brings me to the next question, which is how do we really measure these earthquakes or like tsunamis in terms of your scientific scale? And secondly, in terms of catastrophic, when we talk about catastrophic, if we just talk about it in terms of a scale and number, I think people don't understand it. So if you could just kind of explain it in your analogies as to catastrophic would mean how catastrophic could it get, that would really help us understand this better.
Yeah, for sure. People like to use one number to describe events, right? So when something happened, they always ask, what is the magnitude of the earthquake? People want to know a single number. It is a metric that people use. It is good in terms of describing the event itself. So for example, we use this thing called moment magnitude. So magnitude that people are talking about is actually, in technical term, it's called moment magnitude. And it's actually measuring the size of the faults that are ripping out, that are ripping during this event. So basically, what is the length of the fault that slips during this earthquake? So not all faults, like not the entire length slipping at once, only patches of it are slipping. And depending on the size of these patches that are slipping, the energy that are getting output from this is proportional to that size. However, this metric is just one single number. People like that because it's easy to explain, but it's not really useful because this is the properties of the source, well, the earthquake itself, and not necessarily about the damage. Because as you mentioned a little bit, right, that a bigger earthquake but far further away can actually have less impact than a smaller earthquake that right beneath you. So there's another metric that is actually a better metric that people should be using. So in Japan, they actually use this instead of magnitude that the rest of the world is using at the moment. This thing is called shaking intensity. So it's also a single number. Well, it's also a number, but there is one number assigned for a particular city. So basically, this city get a shaking intensity of some number. It's between 1 to 10, basically. And in this case, instead of having one single number for a particular earthquake, you have multiple numbers based on your location. And once people heard this number, you know exactly what it means in terms of the damage expected and everything else. So this is more useful way of measuring. So it's called shaking intensity, and it's using some numbers. For tsunamis, how we measure it is basically the height of the wave that are when it's actually reaching the sea. So usually by the heights of the wave, because that's determine how the extent of the area that will get flooded during the event. So that's why we use that. Yeah, so these are the general metric that we can use.
That's interesting. I didn't know about the shaking scale, but that definitely sounds more accurate to sort of get an idea of these things.
Exactly. And I think even like the fact that, I never knew that the tsunami's intensity is calculated with the height of the wave. I was thinking maybe, with the amount of damage that can do or something of that sort. But yeah, I mean, it's interesting to hear about that. And again, since we were talking more about like, how we generally measure them and, know all these things, I think I'm not an expert, but still I believe there will be some sort of like a general preparedness method that will be advised by the governments before the disaster happens, especially when it comes to disaster prone areas, right? And they will be using all these measuring devices and stuff to see, okay, whether an earthquake is supposed to happen this time or a tsunami, something of that sort. So how does this awareness thing work when, for the public, for the general public? And also like, when it comes to the policy framework, like within the countries, like, do you know, like, how these preparedness are being put in a clear way by the government?
Yeah, so there are two main things that you can do. So first is to actually in the, I guess, prevention part of the emergency management. So basically you are anticipating that the earthquake is going to come, and now you are trying to doing something to actually reduce the damage that are going to resulting from the earthquakes. So basically you can have a building codes, right? So have some regulation in terms of how the building should be retrofitted. And there's another measure that they use actually. So instead of the measures that we talked, there's also another thing that's called peak ground acceleration. So basically how much the acceleration of the ground is going to be at this particular point. And the building is designed to withstand that number. So basically the number that the engineers need is just one single number. How much do you expect the peak acceleration is going to be at this point? And the building is going to be designed to tolerate that amount of shaking. So that's one thing that you can do. So basically retrofitted the buildings, but it's not the only way you can do it. So basically there's another way that has been popular these days. Especially it has been implemented in multiple countries. So Japan has one, Taiwan has one for sure. The US started to roll out this recently. So this is called the early warning systems. So this is basically not the same with predicting earthquake per se. So a lot of people misunderstood and think that this is the form of predicting an earthquake, but that's not true. So the earthquake already started somewhere. Before the wave travel to your place, it takes time, right? So nothing is instantaneous, so it takes time. And before the wave arrive, you want to try to warn people before the wave arrive at their position. So earthquake wave travel at something like kilometer per second. But our communication, telecommunication, right? Facebook, internet, basically 1 or 2 seconds, you can go all over the place. So basically you have stations, seismic stations that are nearby the earthquake, they start to sense the earthquake, then it procs the warning, and the warning is going to people phones basically. So I can speak from LA in particular. So we have this app called Shake Alert LA, and a lot of people are encouraged to use it now. And basically, before when the earthquake already happened, you will get a warning on the phone. And depending on where you are, if you are directly, if the earthquake is directly beneath you, of course, you are not going to get a lot of warning time, or in most cases, maybe none. But if you are, maybe a couple of tens of kilometers away, you could get 10 seconds of warning time. And that seems like that's not a lot, but it's actually, it could mean life and death in some cases. Basically, getting prepared, go under the table. And in hospital, for example, when the doctor is going to do a surgery, it can be a decision whether am I going to make this cut right now or later. So that's really important. And this 10 seconds that you get matters a lot. And not only this, there's also nuclear power plant that you want to shut down, the main operations, and basically everything. A lot of things, 10 seconds matters a lot, really. So that's why we're people will start to implementing this system in.
Also, coming back to the point about the early warning system, I think at least it will give us time to say, if you are on top of, like, let's say the 20th floor or something, I think it will at least give some time to get down to the ground floor, move away from the buildings or something when the waves hit in. So,
and basically also a decision, right? So if you have 20 seconds, you can think, this is enough for me to get off the building. If not, then the better way is to find a cover, like go on a desk or something. So basically, the numbers matters because it gives you some metric in terms of what's going to happen.
I was going to
just
say,
so fascinating. I mean, I think I'm just lost with the whole roller houses as an idea. I would really want to stay in one just so that I can say I'm staying in a rock and roll house, if nothing else. Other question that has been popping in my head is that we see a lot of talk now in the media and news about how space can help in terms of disaster management. So if you could throw some light upon how exactly could space and space technology help us, and
yeah, that's plenty, right? So if there's none, I wouldn't be on the podcast today with with the Space Association. Well, I guess there are two main things that you can use space to help. So first is, I guess, the GPS system. So basically the same thing that you go and locate where you are on the Earth. You go to Google Map, you click, and the GPS tell you where you are exactly on the Earth. However, for disaster management purposes, you have a much more precise version of GPS than the one that you have in your phone. So of course, the equipment is going to be bigger. It's going to be more permanent, so it doesn't move around like a phone. But basically, it's behaved like a station. So basically, it's a permanent instrument that sit at one spot for a very, very long time. And with the proper analysis, proper techniques, you can actually measure millimeters of movement on the Earth. I'm not talking about meters or whatever. I'm talking about millimeter of up and down,
seriously,
left and right. Yes.
Wow. Okay.
Yeah. It has to be said in a certain way, though. But our technology these days allow us to do that now.
Wow.
And that's basically the reason we can do this is because we rely on satellites and space technology that's going up there. Without satellites, your GPS is not going to work. So I guess the principle in how it works is that you have your phone, for example. Your phone talks to 3 different satellites. And what it does is it sends a signal to the satellite, and the satellite sends the signal back, and it measures the total time that the signal get there and come back. And from the total time, you can actually calculate the distance. And when you know your distance from 3 satellites, you can basically triangulate. So basically figure out where you are based on that. So the minimum number of satellites that you need is 3. But in an ideal world, if you have 10 or 20 or even more, the more you have, the more precise this is going to be. So that's why these things are definitely really useful in terms of positioning where you are on the Earth. And that's also applied to the permanent station that we are talking about as well. So this guy are not relying on 4 or 5 satellites like our phone usually use, but we are talking about like 20 or more satellites to give that precise location. And detecting the movement of the Earth is important because back to the plate tectonics and the movement of the faults, right? So basically, this thing are moving around, and we want a better model about it in terms of how we can estimate whether is there an earthquake potential in the area, and that's how you do it. The second method, second option is about the satellite imagery. So the satellites are flying around, and it look back at Earth and take a sequence of images, and these are really useful for many reasons. First, basically, you can assess the damage from any natural disaster, including earthquakes, in an area that's not easily accessible by cars or by foot. So basically, the satellites are still looking at the same spot on Earth. Well, so how it works is that you have one single satellite that go around, and once it's go above the same location, it takes one picture. And then it go around again, and then same location, it takes another picture. So you have a sequence of pictures of the same area. And basically you can assess whether what happened after the earthquakes or after any event per se, disaster events or whatever type of events. So you can use that to use to assess the damage. And again, in terms of resolutions, the technology are quite good these days. With some of the private satellites, you can actually go up to 1 meter per pixel, which is incredibly good. So you can recognize basically a car, or definitely buildings really easily. A person sometimes.
Let me just interfere here. I think these technologies will be so expensive, like so damn expensive, right?
It is expensive to go to 1 meter resolution, but NASA and ESA actually have a publicly available data sets that's basically from a satellite called Landsat or Copernicus. Those you can get up to 30-meter resolutions, and anywhere in the world, you get this picture roughly every 2 weeks. Anywhere in the world, 30-meter per pixel resolution. So from that, you can do a lot of things.
Okay. So, I mean, since you mentioned like from anywhere in the world, we can access it. What about the open source data that is there? Like, I know like we have all these satellites and you were explaining it right now, like how we can use it to access the data and things like that. But how much of this data is being used by someone as common as me, let's say? Like, how can we access such data, and whether I'll be able to download the data, something of that sort? Like, what's your take on that?
Right. So people don't use them as much yet, but this data are actually closer to our life than what we think. So I think a lot of us use Google Maps, right? There is an option to click satellite view.
Let me just
so
check.
Instead of just maps, okay? So if you go to your phone, we can do it right now, and I'll tell you where to go. So if you go to Google Maps, right?
Okay.
Let it load a few seconds.
Yeah.
You see map. On the top right, there is this weird square shape. I don't know whether you'll be able to see it, but this weird. Well, anyway, okay. So
I saw.
Yeah, there's a little weird square shape on the top right. If you click on that, there's a different map type. There's default, there's satellites, and there's terrain. And basically, if you click satellites, this is the satellite images of your house or whatever. And not sure how many of you heard of Google Earth. Google Earth is a software that you can use online, And basically, it's the same thing. So you can actually look at satellite images in Google Earth, and you can look at your house. How does it look like from the satellite images?
Wow,
But for Google Earth,
I feel so dumb right now because I never knew this was there. Wow, I even
right.
installed Google Earth to get the satellite image.
Right. But Google Earth, it does more than that. So there's actually an option to actually scroll around to see how does this place look like in 2010, for example. So it's roughly one image per year. So there's an option for you to actually go back in time. And it's kind of fun. You can go and see buildings that weren't there in 2010. You can see how cities are developing. And these things are really user friendly to use. So you can do it without needing knowledge in terms of coding or GIS or any software experience. So it's really user friendly. But a lot of people just don't know about it. And I guess one way to learn about it is to join a group like Space Technology for Earth Applications that I'm co-leading. So it's open membership. And basically, we are teaching people how to do all these things. And any of you guys are basically welcome to join.
Yeah, absolutely. I think through these podcasts we are doing right now, we are also trying to, someone not coming from a technological background, like, please, I didn't knew. I'm like, so yeah, I don't think that more than half of the people in this planet is like me, but I strongly believe there will be someone who is as who are not aware of the fact that we could actually access that satellite image from the maps. So that was really interesting. And of course, please do join Pond's project group on SGSE. And
completely unrelated, but the way I heard about Google Earth and I use Google Earth is I do some sort of astrophotography sometimes. And when we have to search dark places, we search it from the internet and then we go on Google Map to scout it, because it's not always possible to travel twice to like really dark locations which are away from the city. So what we do is we try to location scout, and you have an option of like seeing it in like 360-degree view, so you can actually flip it in a manner that you're just walking on the surface. You can see what's down on the surface and where can you climb a hill or mountain from. So even trekkers, for example, a lot of us, we go ahead and map it, and we can map the entire path of the trek so that you don't get lost while coming back, and you can download it on Google Maps and keep. And all this is because of GPS and satellites, which is so amazing. Which makes me wonder, like talking about Google Maps and other apps. I know that you have done a little bit of research on how to use Twitter data and using that in real time to help people in terms of disaster management, which is so cool. And if you could like explain a little bit more about that to everyone, that would be great.
Yes.
Yeah, sure. So that topic is incredibly new. There's not much literature on it yet, so you won't find much information about it. And basically, the idea is since basically around 2010, all of us. Well, I started using Facebook in 2010, and I assume that a lot of people are starting their first social media roughly about that time, 2010, 2011, maybe 2012. And now it's 10 years since we have this social media, and there's so much data available, right? People talking about things online pertaining to disaster. Some people might tweet tweets that, okay, my house is shaking, was that earthquake, or maybe take a picture of a flooding areas that are happening in front of your house, or talking about the damaged road that get blocked by landslides or whatever. Many things that people can tweet about. And the idea is that we have so much data. There's useful information somewhere. Can we learn something from it? It's not really clear. It's not really easy, because if you look at tweets, even get the simple things like where a user is from is not really easy, because some people, instead of saying that, Pasadena, California, like me, they would say from the third planet of the Earth, from my home, from whatever, right? So there are many things that people can use. So these are basically unstructured data, really messy data, but there is something to learn there. And the idea of the project that I run, basically this project was supported by Space Technology for Applications project group that I'm co-leading. So there are a couple of people there that work on that project with me. And the idea is try to learn more about it. So the first thing we can do that we can learn, well, I guess maybe before going to that, let me mention that there was a big hurricane that's actually hit the US, I think last year. It's called Hurricane Ida. Basically, it's created outage the entire eastern part of the US. However, within 1 week, there is more than 200,000 tweets, 200,000 tweets about Hurricane Ida alone. And I'm talking about people that are using hashtag Hurricane Ida, not just any tweet. There could be people who tweet, there's definitely more people that are tweeting about this that didn't actually put the hashtag in. And you can see how much information is available. We're talking about half, like 200,000 tweets. And I'm sure there's probably at least closer to 500,000 or even 1 million tweets about it that didn't use this hashtag. So now what can you do about it? First, you can actually look at basically the rate that people are tweeting. Basically, that's give you a rough idea in terms of how the event is progressing, how people learn about it. And you can see that when Ida is starting in the news, no one discussed much about it. But when it starts hitting the land, like for the first time, and people start to see the effect, you can actually see the jump in the number of tweets on that day. So that's information, one information that you can learn from it. There's also this thing called sentimental analysis. So basically, there are models available online to look at the words. So basically, you give a score to a word. Good would probably be more positive. Bad is more negative. And there are some words that are more neutral. And you assign a number to each of these words. And you can average them and see how the sentiment of people are changing throughout the event. And that's also allow us to learn about some new things that we cannot do in science before. Because if we're just talking about looking at the data, we only know about how the flood or how the hurricane is progressing. We do not know how people react or respond or feel about the event. And that's also an important part. So it's not just about the event itself, but also about the impact that it does on human, right? So this sentimental analysis give us some ideas about what people are thinking. Yeah. So that's what I'm working on at the moment with that project. There's a lot more to do.
Who would have known that social networking sites like, let's say, Twitter have this much power? And I'm still stuck at that point where you mentioned there were like about 20,000 tweets, if I got it.
200,000.
200,000. Wow. Okay, I'm bad at maths, but yeah, like it's a huge number. Wow. I mean, that's really incredible. And also the fact that, for someone who recently joined Twitter, the kind of dynamics that, each social networking sites have, like, let's say from Twitter to Instagram to WhatsApp to Facebook and anything that's out there, I think they all have more power when it comes to like disaster management, not just when it comes to earthquakes and tsunamis, like I think about, right? And I think Pooja have one more question on her.
Yeah, I do actually love how you said that, this, how it impacts people is so important. It's so important to humanize these issues, because otherwise we end up looking at just data as numbers and it doesn't, sink in how bad it is actually. And I was just wondering, you mentioned, I know that you started your journey in terms of astrophysics and then you moved on right now to like Twitter and disaster management. How did you go from astrophysics to disaster management research? If you could just tell us a little bit about your journey as well.
Yeah, sure, of course. Yeah, so I like looking at data, not necessarily, so I'm interested in data manipulations, understanding things from data, especially messy data. Trying to extract information out of it is I think it's fun. And this discipline basically of data or data science in general is not limited to astrophysics or geophysics or anything really. So I just make a switch because I guess I think geophysics, especially studying earthquakes, is a little bit more applicable to the society. So that's why I make a switch. But my interest is to lie in the data science part. What can we learn from the data really? Any data. And now, as you see, so if you think about my career, I started with astrophysics, looking at the stars, learning about them. Then I moved to work on earthquakes a little bit, and still working on earthquakes. And then there is my recent interest, which is about social media, how we can use this data for something else. So basically, it's driven by how we can use the data that are available to us to answer important questions. And that's why I make the switch. So there's no real reason why I pick geophysics and not biophysics or other data science related field really. It's just that it depends on opportunities and what's sparked my interest at a certain point in time.
Wow, that's really interesting to hear about, and like today we are really, really glad that you could actually come on to this podcast done by Space Smurfs and, talk about how space is actually, being used for all these natural disasters, like from earthquakes to tsunamis, and how social networking sites is being used to get the, real-time insights on, how much of an impact these disasters are making. And it's quite fascinating. And it's kind of like, it's something that most of the things I didn't even know. Like, thank you for updating me about Google Maps. I'll be forever grateful for that. Because otherwise, I will be like, okay, how will we get satellite data? I mean, not that I'm someone who uses it always, but sometimes if I'm curious, I can look up Google Maps right now. And I think Pooja, do you have something to add on?
I was just wondering actually that while you were making a point about satellite data and how we have access to it and how it's helping us now in terms of disaster management. I think the people and on the early onset of space programs who were really against it and questioned the expenditure that we put up in terms of space technology would never have realized how much it is impacting us today and how much it is helping us in terms of climate change, in terms of disaster management. So I feel this is just absolutely brilliant. And if anyone ever questions it now, I think we can just like throw them the example of disaster management and make them realize how their question is now obsolete.
Yeah, true, actually. And I think there is a lot more to discuss about this topic, right, Font? Like, do you think there is a lot beneath all these things that we have discussed today?
There's plenty of things. So I do have a final message for everyone, actually, which I think is if you take away nothing, I think this is the last piece that I want people to take away from it, which is the fact that there is this things now called citizen science. Have you heard of citizen science at all?
Yeah.
So basically, we are now in a new era where there is so much data that scientists do not have enough time to go and look through all of them. And I'm sure even if all humans on Earth look at this data, there's still not enough time for us to go through all of them because the rate of acquiring the data is much higher than anyone can ever imagine. But to get involved in these things, if you are excited about disaster management, you want to make an impact, it is actually much easier than you think. So there are many websites out there. The one that I know of is called Zooniverse, zoo like a zoo, like with a lot of animals, and then universe like the stars and everything. And what it is that on this site you can go in and basically you are a person who want to help with science, and you go and there will be a lot of options, a lot of projects available. You click on one of them, and they will teach you how to recognize things. For example, how it's done in the past, because it's actually based on the name Zooniverse. It's actually used for classifying galaxies. So they give you an image and they tell you if the image looked like this is called a spiral galaxy. If an image looked like this, it is not a spiral galaxy. And then after some training, you have to pass the quiz. So there will be a little quiz, and they want to make sure that you know what you're doing. Then they will give you a new image that no one ever looked at before, and you can answer whether this is a spiral or non-spiral. And basically, now it's not just limit to images of galaxies anymore. There are things like uh, remote sensing images as well. So basically identify where you have a road blockage. Is there a damage in this image or not? And basically this help accelerated disaster response and also other science. And it's allow people who want to be more involved as well, because the site will teach you how to do it, and then you will do it. And you will be able to do things that matters. So I encourage you to seek for this citizen science website. I am sure that it is going to be the big thing in the future, and this will be how we can progress forward in terms of the understanding better our world.
Yeah, I think that's so interesting. Yeah, Pooja.
I'm so glad you brought out the issue of Zooniverse. I am actually an art student. I'm not a science student, but I have gone ahead and done one project in the lockdown because I had a lot of time at that time, and I ended up analyzing data from a big telescope on finding asteroids. And there were 2-3 of us who did that in a pair, and we ended up finding one asteroid, which is which was new, which was so fascinating to do. Like just sitting at home, staring at your laptop, you can discover something new in the universe, which is amazing.
Wow. I mean, all I did during the lockdown was discover a lot of K-dramas and K-pop boy bands. And you guys discovered an asteroid. Wow. Okay. That's it.
You were just chilling with other kind of stars. We were chilling with other kind of stars.
I like that. But people who are listening to us, please don't be like me. Please be like Pooja and Pong. We have discussed so far, not the K-pop and K-drama things, but, about earthquakes and tsunamis, how, space has been used for assessing all these things, and how social networking sites is becoming a huge, making a huge impact on for disaster management and everything. There's a lot to discuss. And so those who have listened to our podcast till now, you guys have a wonderful opportunity to converse with Pond here on this Saturday, 26th of February. And please do look out for the timings on our posters, which will be spread through Pooja's LinkedIn, Instagram, Twitter, and also on Slack channel. Please do look out for it and join us for the Clubhouse session. You can ask your questions to Pond directly, and he will be more than happy to answer your questions. So yeah, you would be discussing the topic with him itself. So just keep smurfing and join the Posa team. And Pond, it's a really, really such an honor to actually have you on board today. And like I mentioned, there is a lot that you have made clear to me and Pooja today, starting from the Apple to how the Twitter is being used, for disaster management and things. And we look forward for your session on Clubhouse as well. Until then, take care,
stay safe,
and keep smurfing.